Welcome to Lead Programmer. Today we are going to solve the question minimum number of swaps to make the string balanced. In this question, we have been given a string of even length and it contains the same number of opening brackets and closing brackets. The objective is to return the minimum number of swaps to make the string balanced, and a balanced string would be the one which is either empty or if the order of brackets matches. Let's look at the first example. There we observe that if we swap this and this bracket, then it would result in a balanced string. Similarly, in the second example, here we can first swap this bracket and this bracket. It would then give us this. This leaves us with this bracket and this bracket being unbalanced. So if we swap them, then it would give us the balanced pair of brackets. So this would take 2 swaps in total. In third example, we return 0 because the string is already balanced. So how do we solve this? One thing to observe is if a pair of brackets are already balanced, then we don't care about them. We just care about the unbalanced brackets and we want to swap them to make them balanced. So a first good step would be to remove the balanced brackets. And how can we remove them? Well, we can use a stack to remove them because stacks are the best ways to detect balanced brackets. So that would be our first step, where we use a stack to get rid of all the brackets which are balanced. And at the end, we would be left with just the unbalanced brackets. So another thing to observe is the only way in which we can have a string with only unbalanced brackets is similar to this, where the first half of the string would be closing brackets and the rest of the string would be opening brackets. There is no other way in which a string can be constructed where we have only unbalanced brackets. Well, in that case, we can use this information to our advantage. So let's understand this with a few examples. So the strings over here represent the unbalanced string, that is the string obtained after getting rid of the balanced brackets. In the first example, we have no unbalanced string, which means we return a 0. In the case where we have 2 unbalanced brackets, we return a 1 because the way we can make them balanced is by just swapping these two. In the next case where we have 4 unbalanced brackets, we can just exchange the first and last bracket, which would make the entire string balanced, hence we return a 1. Note that there is no case with 3 unbalanced brackets because of the given constraint in the question where the number of opening and closing brackets are equal and the length of the string would be even. In the next case, we have 6 unbalanced brackets. Here, if we exchange these 2 brackets, then we would get something like, in which case the 4 brackets over here get balanced, leaving with 2 unbalanced brackets. So overall, we can use 2 swaps to get the answer we desire. In the next case, where we have 8 unbalanced brackets, we can do the same thing. If we exchange this bracket and this bracket, we can get rid of 4 brackets. Because observe, we do the same thing here, right? If we have these 4 brackets, then exchanging the first and the last bracket would make this part of the string balanced because we would get something like this. And then we would just have the remaining portion of the string, which again contains 4 unbalanced brackets, and we know that 4 unbalanced brackets can be made balanced by 1 swap. So that's the thing to observe. 4 brackets can be made balanced using 1 swap. So for every 4 brackets, we require 1 swap. So the way we can solve this question would be we just take the number of unbalanced brackets and we divide it by 4 and we take a seal of it, just because in the case where we had 6 brackets, we could have removed 4 brackets with 1 swap. and then we would have 2 brackets remaining. So for that, we would require another swap. So that's why the answer would have been 6 divided by 4, but the seal of it. So the answer would have been like 1 point something, and if we take the seal of it, it would have become 2. So there we have it. The first step is to use a stack to remove the balanced brackets, and the second step is to just take the number of unbalanced bracket and divide it by 4 and take the seal of the entire value. So let's look at the code. So as usual, we first want to count the number of mismatches. So we use a stack and we go through each and every bracket in the given string. If we encounter a closing bracket, then we can check if the top of the stack contains an opening bracket. If it does, we know that is a case where the brackets are balanced. Hence, we can get rid of that pair. Otherwise, we just append to the stack and continue. At the end, we find the number of mismatched brackets by finding the length of the stack. We store that in a variable, and at the end, to find the number of swaps required, we just find the seal of the mismatch count divided by 4. The overall time complexity would be big O of n, where n represents the number of characters in the string s, because in the worst case, we can go through each and every character in the string and store it in the stack. And in the worst case, since we can store n elements in the stack, the space complexity is also going to be big O of n. So let's end this video with a quick last example where, let's say we have a string like, so for this string, if we first go through this part of the code where we get rid of the balanced brackets, then we would have gotten rid of this particular part over here, and that's because let's see how the stack would look like. So the stack would be like this, and then we would have this element, and then we would have this element. Then we would encounter a closing bracket, but we would notice that we have a corresponding opening brackets. So we pop this from the stack, then we encounter another closing bracket, but we observe a corresponding opening bracket in the stack, so we pop that as well. And then we observe an opening bracket, so we put that in the stack. At the end, we see the mismatch count is 2, and we can return the seal of 2 divided by 4, which would be 1. So that's one swap. Hope you found this helpful. Please like and subscribe. See you later.